All right, so example one, in a quadrilateral ABCD, AC is a diagonal, AB is congruent to CD, and AD is congruent to BC. Is ABCD a parallelogram? Is ABCD a parallelogram? Explain. Okay, so we have this theorem again, 611 says converse this theorem 6.7. Both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That's what's happening here. So the purpose of this problem is not to necessarily do a proof of the theorem, but just kind of walk through why this is true. All right, because again, just based on that theorem alone, hey, the opposite sides are congruent, therefore it's a parallelogram. But they've drawn this diagonal line for us, which means that this angle, this is congruent to itself by reflexive property, right? This, like, the explanation is going to be everything I do, so I write down what I do as I do it. AC is congruent to AC by reflexive property. Okay, looking at the triangles there. Here we go. Look at the two triangles we have now. We have side, side, side congruence of the two triangles. Okay, if I'm going to name the first triangle ABC, remember I have to be careful about how I name the second triangle based on the corresponding pieces, right? So A to B to C would match C to D to A. Right, if you're looking at it this way, since we're dealing with sides, I'm going from A past the 1 tick mark through B to the 2 tick marks. So I'm starting at A going this way. So if I'm doing the same path from C to A, you can see here, if I'm starting at C, I go past the 1 tick mark through D to the 2 tick mark. So that's the order of this one. So CDA. By side, side, side. All right, once the two triangles are congruent, now all the corresponding pieces are congruent. So I know that, and consecutive angles are supplementary too also, right? So I know that this angle here, I guess we haven't shown parallel yet. So this angle here is congruent to this angle here. This angle here is congruent to this angle up here, and this angle here is congruent to this angle over here. So that would all be by CP/CTC then, right? So I can say angle B is congruent to angle D, angle BAC, or it's like BCA, angle BCA is congruent to angle DAC, and finally angle BAC is congruent to angle BCA by CP/CTC. All right. So now at this point, by the angle addition postulate, these two angles are the same, right? And these two angles are the same. So let's just, for example, if I call this X and call this Y, and I call this X and call this Y, right? Because those are equal, those are equal. Can you see both these angles are the same, X plus Y? So I'm going to say angle BAD is congruent to angle BCD by angle addition postulate. Okay, once we get to that point where this angle's congruent to this angle, that angle's congruent to that angle. Now we can use the, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is parallelogram. That's the converse of theorem 6.9. So finally I can say that quadrilateral ABCD is a parallelogram by theorem. This is 613. Remember, your theorems have an if-then component to them. The if part must be met to conclude the then part. The if part of that says if both pairs of opposite angles of a quadrilateral are congruent. Well, one pair is congruent B and D, the second pair is congruent A and C, so both pairs are congruent. So the conclusion we're allowed to draw is that it's quadrilateral. So that's theorem 613 to show that. So again, it's kind of, the explanation kind of looks like a proof, but it's not so formal as an actual proof. I kind of skipped a step or two in here too. So, but again, if I'm the reader and I look all through that I buy all that as far as what's written there versus what's written here.